Hello everyone, welcome to Zelin's class, and today we are going to deal with partial fractions. Well, this part is not a very common, so you won't see it very commonly. And well, the idea of this part is to decompose a rational function into partial fractions, such as ax. So we have a whole fraction here, and then we divide into two separated fractions I mean. So the most common one, it's 1 over x times x minus 1 equals 1 over x minus 1 minus 1 over x. Well, we can prove it by just multiplying these, so we can get x minus 1 times x, and here is x and minus x minus 1 times x, and here is it x minus 1. So we will get 1 over x times x minus 1. So that is the most common one. And sometimes if, like this example, we have x minus 5 up here, so maybe we need to use this formula. And how do we solve that? Well, we can assume that this is equal to that, and let's find the value for a and b. So we know that x minus 2 and x minus 3 are going to separate it, so we can write x minus a over x minus 2 plus b over x minus 3. We can write this because this is in the form of that. Otherwise, you can't just write this. So now let's times together, which will get ax minus 3a plus bx minus 2b. And now which is equal to x times a plus b minus 3a minus 2b over x minus 2, x minus 3. And we know that here is 1, so which means a plus b is equal to 1. And here is negative 5 here, which means negative 3a minus 2b is equal to negative 5. And let's solve this simultaneous equation. Equals negative 5, which will get b equals negative 2. And a is equal to 3. So we will get 3 over x minus 2 plus, well, actually negative 2 over x minus 3, which is equal to 3 over x minus 2 minus 2 over x minus 3. And we've done. So it has a very important aspect if we continue to do more questions. So I have a very interesting questions at the end of this video. So let's try to do some more complicated ones first, which is if we have a quadratic up here and a cubic on the denominator. Well, for here we are just, so it's also an equation which will get a over px plus q plus bx plus z over rx squared plus s. And because we know that here is a cubic and here is a quadratic, so we can't just leave a and b up here, because otherwise you won't get a cubic one. So which means that we need to have bx plus c here. So now let's try to expand that. Well, for the x cubed one, we know that x squared plus 3, we know that here is bx plus c, and plus, well, a over x plus 1. And then we do the same thing, we times together, which will become bx plus c times x plus 1 plus ax squared plus 3a. And then we will have bx squared plus b plus c bracket x plus c plus a x squared plus 3a over x squared plus 3 times x plus 1. And we know that b is equal to 2, so we know that b is equal to 2 now. And we know that b plus c, which is equal to 1. A plus b is equal to 2, and b plus c is equal to 1, and c plus 3a is equal to 11. So now we have another simultaneous equations, but there are 3 variables. And let's solve this. So we can get a minus c equals 1, and c plus 3a equals 11. So we have 4a equals 12, a equals 3. And we know that b is equal to -1, and c is equal to 2. So now we have negative x plus 2 over x squared plus 3 plus a, which is 3 plus 3 over x plus 1. So that is the answer for this. Okay, now it's the time to move on to a very interesting questions. This is not in the school syllabus, but it's quite interesting to see how to do this. So it's solving this sequence, the sum of this sequence. So 1 over 1 times 2 plus 1 over 2 times 3 and dot 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 to 1 over n times n plus 1. And well, for this we can, so firstly we have 1, so 1 times 2 here, and we have n times n plus 1 here. So for the denominator, the two, so like the n and n plus 1, they only differ by 1. So which means that we can use this rule here, which is x times x minus 1, so 1 over x times x minus 1 is equal to 1 over x minus 1 minus 1 over x. So which means that n times n, so 1 over n times n plus 1 is equal to 1 over n minus 1 over n plus 1. This is correct because here the x is equal to anything. So we can just assume x is equal to, well, n plus 1. So we can just assume that, and we will get that. And that is for all positive integer n. So which means that 1 times 2, so 1 over 1 times 2 you can divide into, so 1 minus a half. And for 1 over 2 times 3 we can divide into a half minus a third, and so on. So which means that for this equation we can write into 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4 plus 1 over 4 and dot dot dot, and 2 plus 1 over n minus n plus 1, 1 over n plus 1. And that is the whole sequence. And what do you find out? Well, we can see that these two terms, they all cancel out. So what does this mean? Well, this means that the middle of the sequence are all cancelled, and what we left is only 1 minus 1 over n plus 1. And that is our answer, so we can write it like m, so n plus 1 minus 1 over n plus 1, which is equal to n over n plus 1. Well, let's have an extension. What is the extension? Well, now the sequence doesn't end at n times n plus 1, also 1 over n times n plus 1. It doesn't end at here. It is going to the infinity. So what should we do about this? Well, we have found out the first n terms. which is n over n plus 1. And if we want to find the infinity, we can just do the limit, and for n is going from 1 to infinite, and n over n plus 1. And let's just try to do this. And for this, let's divide it by n on both sides, both denominator and numerator, so we get 1 over 1 plus 1 over n. And for this, we can say that because n is going to infinity, so we know that 1 over infinity is equal to 0. So it's going to 0, which means that 1 over n is equal to 0. So what we left is 1 over 1, which is equal to 1. And that is our answer for sum to infinity. Although it's not covered in A2 level, but I think it is very useful to learn about this. And that is all for this session, and thank you for watching this video. And if you want some more questions, you can go to the channel by Daniel Dallas. And thank you.